Hello, everybody. I'm Skip Alzheimer, and welcome to the AV Geeks Lunchtime streaming show. That last film was a castle film, which was made for home markets, and it was silent. There is a sound version of it that I've run across at some point. I just couldn't find it. But this one, instead of narration, had intertitles in between. And the idea was that this was sold. You go to a camera shop where you got your film and you bought your camera and projector, and you would then be able to get a Castle catalog, or sometimes they would keep Castle films in stock, and that'd be something that you could show along with your home movies or the stuff that you shot. A lot of times Castle films were cartoons, or they were kind of cut down digest versions of feature films featuring comedians. They also had a series of sports parades and news parades, all things that were, general interest type of things. And they were for the home film market. So Castle films, pretty great. Let's see. Today we're watching some 16mm films like we always do. So the next film we're going to watch is Discover Flying.
The principle of flight was a historic challenge, baffling men for many centuries. Yet today, after only 2/3 of a century of development, it has become a precise science. In history, man would study the birds and watch their movements for flight. But today, an engineer can determine the efficiency of an airplane design almost entirely by computer. Our study of flight will not, of course, be that involved, but we will study briefly some of the parts of the airplane and discuss generally how these parts perform in flight. The propeller, which is driven by the engine, provides the thrust and pulls the airplane through the air. As the speed of the airplane is increased during takeoff, the special shape of the wing causes the flow of air over the wing to move further and faster than the flow underneath. The difference in speed results in a partial vacuum on the top surface, and lift is created. This lift is increased as the speed of the airplane is increased and accounts for actual flight. At the rear edge of the wing and near the wing tip, the ailerons disturb the airflow, and by moving in opposite directions, simultaneously lift one wing and lower the other. The elevator at the rear of the stabilizer disturbs the air in a similar manner. This entire control surface moves in the same direction, either up or down. When the elevators are moved up, the tail of the airplane is pitched down, nose up. The airplane will climb. When the elevators are moved down, the tail is raised, the nose lowered, and the airplane descends. The rudder at the rear of the vertical stabilizer swings left or right, moving the tail to the right or left. It would be a lot easier to understand the parts we have just been talking about if we could see them on an actual airplane. And so I would like you to meet Jack Kramer and this colorful Beechcraft Musketeer. We've been talking, Jack, about the different parts of the airplane, and perhaps you would like to explain these parts to us.
Fine. Let's start with the wing.
All right.
As you can see, the top surface of the wing is curved more than the lower surface. And as the wing moves through the air, this causes the air passing over the top of the wing to travel further and faster. thereby creating lift. Now let's move around to the aileron. These are the ailerons. There's one located on each wing. They're used in turning the airplane. The ailerons are positioned by movement on the control wheel. If we move this aileron in this direction, the air passing under the wing would have a tendency to lift this wing. At the same time, the other aileron would be in this position, and the air passing over the top of the wing would have a tendency to move that wing down, thereby banking the airplane.
Is a bank the same as a turn?
No, but the airplane must be banked before it can be turned properly.
I thought the tail did that.
Well, it does in part, but let's take a look. In order to make what we call a coordinated turn, the rudder and aileron are applied at the same time. The rudder is moved by the rudder pedals on the cabin floor.
Aren't the rudder pedals also used in steering on the ground?
Yes, they are. You push on the rudder in the direction you want to turn. This is the other control surface located at the tail of the airplane. It's called a stabilator. Its movement is controlled by the wheel in the cabin. If you move the control wheel back, this moves the stabilator up, causing the nose of the airplane to pitch up. If the wheel is moved forward, the stabilator is moved down and causes the nose of the airplane to pitch down.
That is really interesting.
Now let's get in the airplane and look at the instruments.
Okay.
As you look at the instrument panel, you're probably wondering what the different gauges are for. And we'll start with the altimeter, which measures the weight of the atmosphere and indicates our height above sea level. The weight of the atmosphere changes from one part of the country to the other, and we have to make adjustments in the instrument when this happens.
How do I know what the setting should be?
We can get this information from the tower, and then we use this knob to set the small numbers in the window at the right side of the instrument.
Okay, now let me get this straight. We use the altimeter to determine our height above the ground or the altitude.
That's right, the altitude from the altimeter and our speed from the airspeed indicator. It shows us approximately how fast the airplane is moving through the air. This is determined by the velocity of the air entering the pitot tube.
Now where is this pitot tube?
It's located under the leading edge of the left wing.
Okay, the airspeed from the airspeed indicator.
That's right. And now to determine what direction we're flying, we can use either of the two compasses installed in the airplane. This is the magnetic compass, and it's used to determine the direction the airplane's flying. The last instrument we're going to discuss is the tachometer, which is located on the left of the panel. This instrument indicates how fast the engine is running. Now that we've looked the airplane over on the ground, we've seen all of the components and the instruments. We need to take it into the air and fly it to fully appreciate what the airplane will do. Have you ever flown a light airplane before?
No, I haven't.
Well, then why don't we do it today?
Okay.
If you're ready to go, I'll start the engine. This is the radio that we use for two-way communication with the tower, and the microphone we use by holding up close to our mouth and talking into it. When we call the tower, we want to tell them who we are, where we are, and what we want to do, and then we wait for them to give us the instructions. Okay, Diana, why don't you take the microphone and call the tower. Tell them who we are and that we're located in the east parking area and we'd like permission to taxi for takeoff. And you can use this number here for your identification.
Okay. Tower, this is Musketeer 6130N. We are in the east parking area, and we would like to taxi for takeoff, is that? For takeoff.
Musketeer 6130 November, runway 18, wind 190 degrees at 1
tower told us that we are clear to runway 18, which is in that direction. They also told us that the wind was from 190 degrees, which is a little west of south, and that the velocity was 12 knots, which is almost 15 miles per hour. And the altimeter setting was 3002, which we'll set into the little window on the right side of the altimeter now. Now that we're ready to taxi, if you'll put your feet on the rudder pedals and your hands on the control wheel, you'll be able to feel the control movements as we taxi.
Okay.
Now just relax. I think you'll enjoy this. To steer the airplane on the ground, if we want to go to the left, we'll push on the left rudder pedal, and if we want to go to the right, we'll push on the right rudder pedal. Now let's stop here for just a moment and check the engine out before takeoff. There is a list of things we check before each flight. It's known as a checklist. Tower, this is Musketeer 6130 November, ready for takeoff.
Musketeer 6130 November, cleared for takeoff.
Now move out on the runway and line up on the center line. And I'll advance the throttle until we have full power. Keep it right on the center line with the rudder pedals. And as we gain speed and the controls become more effective, we'll smoothly pull the control wheel back until we assume a nose-high attitude and the airplane begins to climb. Now that wasn't hard, was it? Let's climb up to an altitude where the air is probably smoother. And we'll start by turning the airplane. First, let's bank to the left by moving the control wheel to the left and pushing slightly on the left rudder pedal. Notice the horizon. To recover from this turn, push on the right rudder pedal and move the control wheel back to the right until the wings are level with the horizon. Now let's do that again. Always look in the direction you will be going before you turn. To turn the airplane to the right, we'll move the control wheel to the right and apply right rudder. To recover from that bank, we'll move the control wheel and rudder pedal back to the left until the wings are level again with the horizon. Now let's try some climbs and descents.
Okay.
To climb, we'll pull back on the wheel until the nose is up above the horizon, and to put it back down in level flight, we'll move forward with the control wheel. To descend, we push forward on the control wheel until the nose is below the horizon, and to bring it back to level flight, we'll pull back on the control wheel. The airport is off to the right, so let's turn in that direction. Now line the airplane up with the runway. Now we need to lose some altitude and slow the airplane up. So we'll start coming back with the throttle, reducing the power, keeping the airplane lined up with the center line of the runway. That's good. Now start coming back on the wheel. Just a little more. Very good. Keep coming back until we touch down on the main wheel. Good job. After a few more lessons like this, you should be ready for solo.
Well, thank you. I really enjoyed this lesson. I hope you two have learned a great deal about the airplane and flight and have enjoyed my experience of discovering flying.
Well, that was incredibly hip and awkward at the same time. That music was really great. Her hair, of course, really great. And I appreciate all the airplane quotes in the comments. I think I have a couple other films in this series. I got this from a university. I think it was Rhode Island, maybe? So maybe they taught flying. But yeah, it's kind of great. All right, time to watch something that we have set up on the telecine. The German thing that I had made. Well, I didn't have it made. They made them. But delivered from Germany. And more than once I had former East Germans in my archive/house repairing this for little tiny things. And one of the guys, both of them smoked. There were two separate occasions. And both of those dudes smoked like crazy. And one of them was really interested in blue jeans. You know, I guess that's the communism thing. And he was looking for a certain Levi model. And it turns out that in the United States, that number is for women's jeans. But I took him to like 4 different places to look for Levi's, including an outlet mall. And it's the things you do. Anyways, they were nice guys. Just barely spoke English, but, we made it work. All right, so anyways, I have a film threaded up here, and we're going to watch Mystery Map, which is Canadian, but distributed by Encyclopedia Britannica, and is one of those open-ended films that we love. So here we go, Mystery Map.
Come on, kid. Get out of here. Come on. You're not supposed to be past that fence.
Hey, mister, can I have that?
What?
That.
This? Don't seem to be nothing in it. It's only a rusty old box. Sure you want it? Here. Wait. Okay. Now you watch how you handle it. Get out of here.
Okay, thanks a lot.
Go on.
Hey, Danny, what do you have in that box? Never mind. Oh, come on, tell me. Put it in, Kathy. Humphrey, you're it, Kathy. That doesn't count. I wasn't even hiding. That so counts. Okay, but first let's see what Danny's got in that box. Come on.
Hey, Danny, come on to the clubhouse for the seals out here.
Okay.
there's nothing in it.
Wait, there's something stuck to the bottom.
It's small pieces of paper.
Here, you read this one.
It's just a dumb poem.
What does it say?
Follow the map and do not stray from the places marked along the way. Travel fast or travel slow, but only one way you must go. Follow the map from street to street with only the help of your own 2 feet.
Hey, this one must be the map.
That's what it is.
There's where we have to go, to the zoo, see? There's a tree right here, right next to where the zebras are. But how do we figure out where to start? The streets aren't marked.
We can figure it out. We know where the zoo is. Look, start at the zoo and work your way back. Let's go. But why don't we go straight to the zoo instead of all over the place?
What does the poem say?
Follow the map and do not stray from the places marked along the way. Guess we better do what it says.
Okay, let's go. What if they see us? We'll stay far enough behind so they won't. Come on, we have to keep up with them.
The houses aren't there anymore.
They must have been torn down so they could build this parking lot. Boy, this map must be really old.
There's the laneway. Let's go.
Come on, you kids, out of here. Come on. Come on, get going. Come on, move. Move. And keep going.
How do you know they'll come to the zoo? You heard them. The zoo is on their map. Here they come.
Wait a minute. Let's look at the map.
See, the places are all around here.
Yeah, but there's more than one tree. I'll look over there. You look at around those.
Okay. See anything?
Not so far. Where did you come from? Hey, look what I found!
What is it?
What is it?
What is it? It's a key. What are you going to do with it? Can I hold it?
Not until I and Danny are finished with it.
Oh, come on, just for a minute. I'll give it right
What's that
back.
you got, young fella? Does it belong to that little girl?
It's just an old key. We found it in a tree.
Why, that looks like one of the old play keys we used to have in the old days.
What's a play key?
Well, we used to call it that because they were just for fun. Years ago, we used to make up play maps, and my children and their friends would follow the map and find one of these.
Is this one of your maps?
Why, that's one of my maps, all right.
We followed them all the way.
Now, that's the way it should be. We made the maps so they'd be so easy for the little ones.
You can keep it.
No, it's yours. You found it.
No, here, you can have the map, too. It's really yours anyway.
Thank you. Tell the truth, I'll be really glad to have these. Help me remember the fun we used to have in the old days.
Here, come on, let's go home now.
It's just a rusty old key.
Yeah, sure is funny looking. Looks too old to be any good, though. Do you want it?
No, might as well throw it away.
No, don't throw it away. If you don't want it, give it to us. Well, you promise not to follow us around anymore. We'll give it to you. Promise? We promise, don't we, Joey? Is it for a door? Maybe. Maybe it's for a treasure somewhere. If we could find it, we'd be rich. What are you doing? Seeing if there's anything else in here. Hey, I feel something. Feels like a hole. A pea hole in the tree. Does it fit? Wait, it's kind of hard. It does fit, Joey. Should I turn it? so was the keyhole.
Boy, this key must be really old.
Can we see too?
Why didn't you enjoy go and play? How'd you get here anyways?
We followed you all the way. We can just go right home. Don't be so mean. Show me the key.
I've never seen a key like this before. I wonder what it's for.
Hey, maybe my grandfather knows. Come on, let's go.
Wow, that key's the key to the city. I remember when it was stolen. It must have been more than 50 years ago. They never did catch who it was that stole it, and until now, they've never been able to find the key.
What do you think we should do with it?
Oh, hang on to it. We'll go out and telephone the mayor right now. Just wait till he hears about this. Come on. Come on.
Where are we going first, Mr. Mayor?
This is your city, Joey. Where'd you like to go?
Everywhere.
All right, so many of you have seen this woman before. I don't know her name, but she and many like her show up in the leader, the countdown leader, either at the beginning or at the end of many, 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 many films. They used to be called China Girls, but more recently they're being called leader ladies or leader lads because sometimes there's men. Sometimes there's a mannequin head, which is really creepy, or a child's face. And this was helpful for film processing labs to kind of make sure that the batch of films that they were doing were coming out okay, and that the color density was correct and the flesh tone was correct and all that stuff. And sometimes you can do color correction based on this. I don't know. The next thing that you'll see is the three colors, that green, blue. That's another way that you can sometimes calibrate. So there you go. We just learned something there. And I have a bunch of leader ladies. And at one point I put out a calendar of a bunch of them that I found in commercials that I had. And it was a wide variety of them. Some were Kodak, some were women from different countries. Some were the same woman, but she was doing something a little bit different. And that previous woman that we just saw, that previous leader lady, I have footage of her blinking, which is pretty great. And she shows up in a lot of Learning Corporation of America films. So it's pretty cool stuff. Let's learn about the pioneer of progress. Let me say that again. Pioneer of progress.
was behind America's dramatic Pioneer Days expansion. From his smithy came horseshoes and wheel rims of iron, and later of steel. The prairie schooners that opened the continent rode on the blacksmith's products. The pioneers who voyaged out across the plains depended only on themselves. They relied on their own faith, courage, and resourcefulness. But steel axe heads to hack out clearings in the forest for their homes, was their great ally. The pioneer's axe conquered the forest and made of it a place to work and live. Steel saws cut the forest into logs, and steel tools shaped the logs into boards to make dwellings for the pioneers. Steel plows turned the earth into farmland to feed the country's growing appetite. But ours was a horse and wagon civilization until a new pioneer, the iron horse, came snorting and puffing across the prairie to increase the rate of America's progress 100-fold. The railroads flung across the land a network of steel rails that bounded into one nation, more prosperous than anyone had dreamed any nation might be. Today, steel and the industry that produces it continue to serve the pioneer spirit. Thousands of steel products pour from America's mills. Modern pioneers opening new frontiers. Frontiers which offer greater happiness, security, and prosperity for our nation. America's steel industry is big business. It's more than 250 companies make about 40% of the world's steel. Yet, it is small business too, for it's owned by over 750,000 people. 1 out of about every 200 Americans owns steel stock. Nearly 700,000 men and women work in the iron and steel industry, and they're among the world's best paid workers, earning around $4 billion a year, or an average of more than $20 a day. The making of steel is a complicated, highly skilled process, using the talents and crafts of hundreds of thousands of people. In this open hearth furnace, the raw materials, steel scrap and pig iron, which was made from iron ore, are blended into steel. Along with these ingredients goes a carefully measured quantity of limestone to change the metal's impurities into slag, which will later be drained off. The molten steel is cast into ingots. These weigh about 6 tons, but size varies in different plants depending on what is to be made from them. Removed from their molds, the ingots are placed in a soaking pit. This is an oven which equalizes the ingot's heat, bringing the entire chunk of metal to an even and very high temperature. The buggy carries the white-hot ingots to the rolling mill to be formed into useful shapes and sizes. American mills can produce more than 135 million tons of steel ingots a year. The ingot arrives at the rolling mill in its white-hot, malleable form. It will be squeezed and kneaded back and forth through a series of rolls, and then into a wide variety of plates, beams, pipes, rails, bars, and other marketable shapes. The men who guide the ingot through the rolling mill are typical of the industry's most highly trained technicians. Operation of the mill might appear entirely automatic, but no mechanical device can take the place of skill, experience, and judgment. For steel making is more than a business, it is an art. Gradually, the steel is shaped into new forms. This is a section of a rail, and like every steel product, it must be flawless in form and quality and must meet rigid specifications. For that's the rule in a free, competitive society. Good workmanship builds a good business, and competition guarantees the highest standards of production. Americans today are pioneers. though we travel in express trains instead of covered wagons. No uncharted territory remains, but there are other frontiers, and we conquer them in the pioneer way, through our own initiative and resourcefulness. And steel, even more than it was for the pioneers, is our ally. Steel-framed buildings sheathed with stainless steel open new frontiers in the sky. Steel bridges span our rivers and bays, and steel machinery helps bring our mineral wealth into use. The ships that sail our waterways, helping to make the United States a world leader in commerce and industry, are ships of steel. It's used for farm equipment to help make us the best fed nation in the world, and our farmers the most prosperous. Steel vehicles carry us through the streets of our busy cities, cities whose very backbone and framework are of steel. When an American goes on vacation, he's likely to set out across the country in his own car. The car he drives is of steel. The concrete highway is reinforced with it. From steel come the weapons to keep our country free. In the traditional American way, our nation's steel companies help America handle not only the defense needs of the moment, but those of the future. This voluntary production means that our fighting men, wherever they may be, have the best equipment that mill, engineer, and technician can make. Steel keeps America safe now, and a freely growing and developing steel industry guards our future as surely as these big guns, guns of steel, guard the freedom and security of America and the entire free world. As our steel needs increase, new mills and furnaces are constructed. These mills provide a vast livelihood for countless thousands of other workers and businessmen. A man who makes conveyor belts for ore mines, a bookkeeper in a Great Lakes shipping company, or a driver who handles huge earth-moving equipment like a toy. Large-scale expansion and improvements since 1946, privately financed, have raised our steel-making capacity to about 2.5 times Russia's full total. It exceeds the annual output of Great Britain by about 6 to 1, and it exceeds the output of France by about 9 to 1. In steel's laboratories, scientists strive continually to develop new and better products. Millions of dollars of private capital are spent in the search for new uses for steel, better and safer ways of making steel, new ways to expand its production, and to develop raw material reserves the world over to feed our ever-growing demands for steel products. The gigantic electric steel-making furnace is an example of the endless research. In this furnace are manufactured the highest grades of steel for automobiles, aircraft, ball bearings, surgical instruments. The ingredients to be melted are dropped into the top of the furnace. Now the heat has to be increased, in some cases up to 3,500 degrees Fahrenheit. For this enormous heat, the furnace uses enough electric current to light a city. Between 3 electrodes and the metal below, tremendous man-made short circuits leap back and forth. The skill and judgment of the melter are all important in a job like this. A special instrument is used to judge the molten metal's temperature. It's pronounced okay. While developing and expanding methods of making steel, the industry scientists also have made steel making safer. Thanks to their research, hazards are minimized in handling even liquid hot metals like these. And steel is now one of the safest industries for the men and women who work in it. In this wire manufacturing plant, steel is rolled into a rod and drawn out into wire. From it will come an infinite variety of steel products, ranging from cables holding up a great bridge to a tiny pin. Whatever the final product, the wire is checked to make sure it fits requirements precisely. A tin plate mill takes steel and turns it into tin plate for what are popularly known as tin cans. The so-called tin can, a product that has revolutionized American living, actually is only about 1% tin. The rest is steel. So it's more correct to call it the steel can. Most of the tin plate produced in the United States is shipped to the container industry, approximately 1/2 of it going into food cans. The United States produces about 3/4 of the world's tin plate. We are also the world's largest tin plate consumer, using more of it than the rest of the world combined. Steel, racing along here at 30 miles an hour, is made into more than 20 billion cans for food alone each year. Many more cans are needed for oil, tooth powder, paint, and other products all over the world. The gleaming tin plate is cut into convenient sheets, and before these are sent out to be made into cans, careful inspection. A few moments ago, we saw battleships, bridges, and skyscrapers. In smaller ways, too, steel carries on its pioneering job, ways that bring it into the home and the life of every one of us. Cookie cutters, pie plates, humble but essential articles. Stainless steel, doing the jobs that only steel can do, goes to work in the modern processing of food, helping to raise our nation's health standards. Steel comes into every home, pioneering new ways to make life easier and better. Each steel company vies with more than 250 others for the patronage of the best customers in the world, the producers of America's essentials and conveniences. A steel hairpin, for example, making for a woman's happiness. Every one of us, every day, uses steel in hundreds of ways, and we start using it almost from the instant we are born. America's free competitive economy depends and thrives on a free competitive steel industry. From a razor blade to a skyscraper, steel builds our nation. Steel, from a hypodermic needle to a pipeline that stretches out across the country. Steel, from a whirling egg beater to an enormous suspension bridge. Steel, from a needle in the hands of a woman to the hull of the world's fastest ocean liner. Steel, from the ticking mechanism of a watch to the framework of the world's tallest building. Steel, pioneer of progress in America's past, enriches our nation now and opens new frontiers for America's bright future.
Steel! 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 That was 1953. So post-World War II. The hidden agenda, of course, is stop regulating us, stop making us, with our labor laws, stop regulating who we're selling to, stop keeping us from affecting the price, manipulating the price of steel, all those things. It's like, get off our backs. We are America. We're American way of life and American jobs. That's us. Steel. Here's some movie trailers from the 70s.
He was the best. He killed the rest. The master killer, the master of the martial kung fu art. Revenge drove him on. Vengeance would be his. The Manchu warlords would pay for their crimes. See the master killer, the greatest artisan of kung fu. He is the best. The Master Killer, rated R, from World Northall.
Was it Arak? Was it Arak?
One man's obsession turns the cold north into a blazing battlefield. The Capture of Bigfoot, not a documentary. The Capture of Bigfoot, now playing at a theater near you, rated PG, parental guidance suggested.
Black belt against black magic in the greatest battle of all time. As the seven brothers and their sister meet Dracula. Die, Dracula, die! See the 10,000-year-old monster disintegrate before your eyes. Black belt against black magic in the greatest battle of all time. The Seven Brothers meet Dracula, rated R.
You are about to experience terror. Terror is being alone in a dark house. Terror is being pursued by the devil himself. No one can escape terror. Terror, rated R.
Yeah, so I have a bunch of reels of old TV trailers. So these are trailers that would be shown on television. So they tend to be 30 seconds, 15 seconds long, short little things. Not as long as what you would see in a theater. And certainly what would be shown in a theater might have, nudity, profanity, violence. And that would not be the case for these television things. But I got a bunch. And I used to show more earlier, like last year when I was doing this, and I lost track of what I had shown. So I'll start showing some more soon, but I might accidentally repeat stuff, so I hope that's okay. And then also, I have sometimes 10 copies of the same trailer that I just kind of spliced onto the reel. So anyways, thanks everybody for tuning in today. It's always great to see you, to read your comments. If you like what you saw, you can always hit like, or subscribe, or the thumbs up, or a little bell, or whatever it is that, your social media tells you that you should hit to say, yes, positive vibes. You can also buy us coffee. Coffee stimulates our nervous systems and keeps us going when things get tedious. avgeeks is not all about showing you films. Sometimes I have to enter things into a database or a spreadsheet, or I have to splice hundreds of reels of little tiny reels of TV trailers onto bigger reels. All that stuff helps, and coffee certainly helps. You can also visit avgeeks.com. I'm going to be back at 3 o'clock, kind of through YouTube and Facebook and all that, with an expert from NC State, and we're going to talk about films to talk about air pollution and ultimately climate change. Including a film in the 50s that basically says, yeah, if carbon dioxide builds up, then the Earth will heat up, and that's a problem. So join me at 3 o'clock. Otherwise, come back Monday. And I'll see you then. Everybody have a good weekend. Please rewind and love each other, and I will see you soon.